Beyond their reputation as cosmic devourers, black holes, especially the supermassive ones at the heart of galaxies, play a surprising and vital role in shaping the universe. These colossal entities, millions to billions of times the mass of our Sun, are not just destructive forces, but are key to galaxy evolution and structure. They act as cosmic recycling plants, influencing the birth and death of stars and the very morphology of galaxies through a process known as AGN feedback. When matter falls into a supermassive black hole, it doesn't just disappear. It forms a hot, luminous accretion disk. This disk emits intense radiation and powerful jets of particles that interact profoundly with the surrounding gas and dust within the galaxy. This energy, known as active galactic nuclei or AGN feedback, can dramatically regulate star formation. Often, the radiation and jets heat, ionize, or expel gas, preventing new stars from forming, a process called quenching that leads to red and dead galaxies. However, in some instances, these powerful outflows can compress gas, paradoxically triggering bursts of new star birth. Supermassive black holes also generate strong outflows and galactic winds that effectively clear interstellar matter. These winds, driven by radiation pressure or jets, can travel vast distances, fundamentally altering a galaxy's shape and the distribution of its gas. The activity of these central black holes significantly influences a galaxy's overall morphology, affecting the growth of its central bulge and leading to distinct shapes like elliptical galaxies. Crucially, black holes also participate in a grand cosmic recycling process. Expelled material, enriched with heavy elements forged in stars, can eventually return to the galaxy, fueling future generations of stars. This intricate dance highlights a strong correlation between galaxy properties and supermassive black hole growth, suggesting a profound coevolution. The mass of a supermassive black hole is often directly related to the mass of its host galaxy's bulge, indicating their intertwined development over cosmic time. Theories even suggest that supermassive black holes were crucial in forming the very first galaxies, acting as gravitational seeds for their formation. Despite significant progress, many details of these feedback mechanisms and the precise coevolution remain unclear. Future research, especially with advanced telescopes like the James Webb Space Telescope, promises to unlock new insights into these cosmic mysteries. The universe is a dynamic, interconnected system, and black holes are far more than just cosmic drains. They are architects of galactic evolution.